Welcome back to the channel. Today I'm building this up into my dream gravel bike. I did an in-depth inspection of this frame in my last video, so check that out if you haven't seen it yet. Also, a quick update on that video. Apparently the zero offset seat post from Quick's AR1 is compatible after all. I will get one and see if it solves my biggest issue with this frame. But now, on to the build. I'll be installing the latest SRAM XPLR group set on here, and if you're planning to do the same, I highly recommend watching the official SRAM installation videos. I'll link the relevant ones in the video description. Don't just trust some random guy from the internet, especially when it comes to safety critical steps like the brake bleeding procedure. Lots of builds start with cutting the steerer tube to the correct length, but if you cut it too short, that could turn into a pretty expensive mistake. I already did some math on the stack height in my last video, but I want to be 100% sure, so I'll take some measurements first. And to make that easier, it would be nice to have some wheels. So let's jump back a few days to the part where I built them up. For wheels, I'm keeping it Chinese with the Yoeleo SAT C45 DB Pro NXT Gravel, which is basically their top of the line gravel wheel set, but more of them in a second. Let's first take a look at the other components. The Casette is just the standard 13-speed Explorer cassette from SRAM. The tires are 2 for Thundero in 44mm because they are fast, affordable, and I already have them on another bike and they seem to last quite a while. For rotors, I've chosen the Caliper Wave because they are light and affordable, but a little warning on them: if you are a heavier person like me and you're planning to do a lot of descending, they are not the rotors for you. I've ridden them in the Alps, and on steep descents it takes like 1 or 2 switchbacks and they are completely faded because the price of the little weight is the very little thermal capacity. So keep that in mind, but for our gravel build here, they are totally fine. Another thing to keep in mind when using these wave rotors is the way they wear, because you cannot check the remaining life with calipers like you would do on other rotors. The reason is that they wear out a lot faster on these sections here with very little material. I've kept this particular rotor a little too long on my bike, and as you can see, there's almost nothing left here, while the track on the outside still looks good. So instead of checking the rotor, you have to check your brake pads for a wavy pattern, and if they develop that, it's time to change out the rotor and the pads. But enough of rotors, there are other things we need, for example tubeless sealant. I've chosen this because it's cheap and it does the job. Everybody has their favorite sealant, go with whatever you like, I don't really have a recommendation. Then we need a pair of tubeless valves. For our 45mm deep wheels, I've chosen the 60mm valves here. And as a final part, I'd like to mount a speed sensor on my rear wheel. They cost like nothing on AliExpress, so why not? And these are all the tools we need. First, this little one here to unscrew the valve cores, then a simple set of tire levers, a big syringe to inject the sealant, and an air booster to seat the tire on the rim. You could also use a CO2 cartridge or a compressor, but you need something with big airflow to seat the tire. To mount the rotors, we need this lock ring tool with 16 notches, and to mount the cassette, we need a little bit of grease and this cassette lock ring tool. I can recommend this one from Park Tool with the alignment pin here. It makes life a lot easier. And I'm combining this with a 1-inch socket so that I can mount it on my torque wrench. Speaking of torque wrench, you'll need a big one that's at least capable of 40 Newton meters. Now we have all our tools together, let's start the build. So nowadays, every single piece of cycling equipment has to come with some inspirational stuff on it. That's how you know it's good. This is the packaging, really nice. So let's take out the wheels. And we're left with one mystery box. Let's see what's in there. That's not a lot of content. Nope, nothing more in here. Just 2 spokes and some valve extensions. Why extensions and not valves? I hope nobody sets these wheels up with tubes. There are a few reasons why I chose this wheel set. First, it's super light. The pair weighs in at just 1,380 grams, so just as specified by Yoeleo. Second, it's one of the widest wheel sets on the market. Yoeleo claims 34 on the outside. We have 34.3 and 27 internal with 27.1. So these things are massive, and the advantage of that is that in theory the tire doesn't blow up as a balloon, but more in a U shape, which should make the whole wheel-tire combination a little bit more aerodynamic. But we will see. Another feature I'm really excited about is that the rim bed has no spoke holes. That means we don't need rim tape, we will never have to maintain rim tape, and we will never have a leak inside the rim. Then we have some large drain holes, one on each side. And I don't understand why these don't come with every rim, because at some point water will come in through the nipple holes and it needs a way to come out again. And another purpose of these is that you don't accidentally pressurize the rim cavity. In this case we have no spoke holes, so the chances of that happening through the valve hole here are not that great, but it's still good to have them, and if you don't like them you can just tape them shut. Okay, so let's get to work then. The very first step is the installation of the tubeless valves, and like on many other valves you can use the dust cap to unscrew the valve core. I'm doing this because this is where we will insert the tubeless sealant later. Then unscrew the nut, and don't forget the O-ring, because this conical seal here is the only one that goes into the rim. Now slide the O-ring back on and tighten the nut. Don't need any tools for that, just so that we have a nice seal on the inside. And we are done. Two things are important when installing the tire. First, you need to install it in the correct direction, so you know that the chain goes on the right side, so this will be the rotation later, and the thread pattern has to match that. On most tires there's a little arrow, but I can't find one on these. But yeah, from the thread pattern it's pretty clear how they are supposed to go onto the rim. And the second important thing is to align the logo with the valve, because optics is everything. So I just start by hand and see how far I come. Almost all the way around. Okay, I need a lever for the last little bit. Okay, that was easy. One side installed. Check the alignment. Now you still have the chance to correct it a little bit. And then mount the other side. Wow, these tires go on so easy. I think this was the easiest tire install of my life. Okay, so I've got myself a little helping hand here and I'm ready to fill up the tire. I think Stans recommends something like 80 milliliters per tire. I think that's a little much, so I'll go with around 60. I'll fill up that syringe over the sink and then be right back. Here we go. Just in case, I prepared some paper towels. So one trick to don't have the sealant spill out again is to depressurize it from time to time and then continue with the inserting and depressurize again at the end. And that's it, not a single drop spilled. If I would pump up the tire now, nothing would happen because it isn't properly seated on the rim yet. And to seat it, we need a big air boost to pop it into place before all the air can leak out again. For that, I've got this tire booster from Schwalbe here, and I will press the hose onto the valve. Note that I haven't installed the valve core yet because I want maximum airflow. So I just press it against here, I don't screw it on, and when I'm ready, I release the booster. That's it. So now we have pressure in the tire, and now I will release the hose and put my finger on the valve. And that's it. Now comes the tricky part where I have to screw in the valve core without losing all the air again. And I use the valve core tool to screw it in a little bit more. And you can hear some leaks, but these will go away once I shake the whole assembly a little bit. And that's it. Tire is seated and almost sealed. I will now pump it up to maximum pressure to make sure it's really seated and then check the control line. This tire is rated for 60 psi, but it didn't even need that. it popped into place right away. So you can see that the control line is visible all around. And if that's the case, we are done. So onto the cassette. I'm still amazed by the size of that thing. Like, compare that to my normal road cassette. This here is chainring territory. It's gigantic. But the installation is super easy. When installing a cassette on an XDR FreeHub body, all you need is the cassette itself. No spacers, no lock ring, no nothing. You just put a little bit of grease onto the threads here, and then you screw on the cassette. You might have to give it a little push so that the threads can engage, and then this lock ring tool with the alignment pin comes in handy because it allows you to safely apply some force without slipping. So let's see if I can do that in my improvised work stand here. Okay, so once that is tight, I'll switch to the torque wrench. The torque wrench is set to 40 Newton meters, and now I will give this one click. That's it. Cassette installed. Before you mount the rotor, don't forget the speed sensor. I just put it on off camera because after mounting the rotor, it gets really hard to access the hub. Or you could just put it on the front wheel, but then you'll miss out on some very marginal aero gains. Mounting the brake rotor is as easy as mounting the cassette. You just slide on the rotor like that and then secure it with the lock ring. Be careful, the Galfa lock ring comes with this silver ring, and this has two sides. The ribbed side goes onto the rotor like this. And there's already thread locker applied from the factory, so we don't have to add anything here. And again, tighten with 40 Newton meters. It even says so on the lock ring. That's it, the wheel is completely assembled. Just one more thing, wipe the rotor with brake cleaner before you put it into the bike, because you don't want to contaminate your new brake pads with grease from the workshop or from your hands. So while I will continue with the front wheel, you can continue with the rest of the build. The rear wheel is already on, and I know the derailleur hanger is not meant to take a 13-speed cassette, but for a drive fit this will do. For the front wheel we first have to install the fork, and I'll start by peeling off the ridiculous amount of QC stickers here because I don't want them to fall off and get eaten by the bearing eventually. When it comes to headset bearings, it's super important to not mix up the top and the bottom one, because they will fit on either side, but they will not live a long and happy life if you do it wrong, and they might even damage the frame. They come in these labeled bags, but if you've already ripped them open and can't remember which one is which, there are a few ways to identify them. The top bearing has a 45-degree chamfer on the inner ring, while the bottom bearing has 36 degrees. And you could easily check for the 45 degrees with a square object, and you will see that it makes contact over the whole chamfer. So that means this one is the top bearing. Alternatively, you could take the compression ring that goes into the top bearing and see if its chamfer matches the one on the inner ring. And on this particular headset, the chamfer on the top bearing is a lot smaller than on the bottom bearing. So now that we have them identified, let's pop them into the frame. The crown race, known from steel forks, is already integrated here. So without any additional parts, we can just slide the fork in. And for now, I will fix it with this large rubber band here to the down tube. The compression ring just slides over the serrate tube and is seated into the upper bearing. And on top of that goes the bearing cover that in this case unfortunately has no rubber lip or seal, so water can and will get in here. So we should definitely put some grease in here during the final assembly to ensure a long life of the bearings. To measure the saddle to bar drop, we obviously need a saddle, and I've decided to go with the Selle Italia SLR Boost Kit Carbonio Superflow because I think the name is hilarious and it's one of the comfiest saddles I've ever ridden. On the seat post we have a 2-bolt clamp, which I think is vastly superior to a 1-bolt clamp, especially in a case like this, where we have to slam the saddle all the way forward. With a 1-bolt clamp there's always the risk of the clamp slipping and the saddle tilting while riding, and this can't happen here. The bolt in the front can only be accessed from the top and needs a 4mm hex key, while the bolt in the back is accessed from the bottom and needs a 5mm hex key. Now that saddle and handlebars are on, we can finally take the measurements. For that, I've adjusted the saddle to my preferred height and put a laser through the bottom bracket and on level with the saddle. This allows me to easily measure the setback, which comes out at 80mm with the saddle slammed all the way forward, and that's way too much, so we definitely need that 0 offset post. The saddle to bar drop is measured like this, and with a 5mm spacer I get to my preferred 100mm of drop. Obviously you can do this without a laser, but it makes it much easier to copy a position from one bike to another. And now that that's done, we can finally cut the steerer tube. The tube has to be cut so short that it cannot touch the top cap later. I'll explain why after the cut. I now double check one last time that all the bearings and spacers are seated correctly, and then I mark the tube with a knife just above the handlebar. I now have to cut roughly 3mm below that mark because I want a gap to the top cap, and I also have to take into account that the expander plug takes up 1mm or so. There are many tools for helping you with straight cut. I just printed my own and I slide it on and put it exactly on my mark. Then the saw blade goes in from the top and everything gets clamped up in a vise. This way I will automatically cut at the perfect position. But I will do that outside and have a vacuum running while doing it. I must say I'm a little bit proud of how well my little jig worked. That's a clean cut. So now we can install the expander plug. Opinions are divided on whether to use grip paste or not on this one. I've never had issues with paste, so I'm going to apply some. The frame doesn't come with instructions or torque specs, so I'm going to give this 6 Nm for a start. We can always go higher should it slip. But what is even the purpose of this? Well, if I install the fork now, even with the compression ring in place, the whole system is still pretty loose. And for that to change, we need to pull the fork upwards into the frame. And by that, we wedge the lower bearing in between the crown race and the inner interface of the frame. And that centers the fork automatically at the lower bearing. At the top, we have this compression ring or wedge ring, and this one is split, so it can change diameter a little bit. And when that ring is compressed into the upper bearing, that slot closes and the ring grips the steerer tube. And by that, the whole fork is now securely in place and all the play is taken out of the system. And this is where all the magic happens. By tightening the so-called preload bolt, I'm now pulling the fork up by the expander plug while simultaneously pushing the handlebar down on the wedge ring on the top. And this is why it is so important to not cut the steerer tube flush with the handlebar, but instead cut it a few millimeters below, because we need that little gap here for the compression to happen. If the top cap would touch the compression plug, then I would just be compressing the top cap onto the plug and nothing would happen below. That's one of the most critical parts of the build done. It only gets easier from here. But I'm going to disassemble this once again because it's now time to route the brake hoses through the frame. To do that, we have to cut the brake hoses. But first I suggest you take the lever and give it a few squeezes, and then you remember that feel, because that is how it should feel in the end after the installation and bleeding procedure if you've done everything right. The first step of the brake installation is identifying the correct bolt length and brackets for the caliper installation. For this we need the SRAM caliper mounting specifications, some measurements and a little bit of thinking. The bracket already comes pre-installed with the caliper, but if we need it depends on our rotor size and the frame dimensions. On the rear wheel I've mounted a 140mm rotor with a B dimension of 36.5mm. The specifications tell us that we need no bracket, so I'm going to take this off. The specifications also tell us that for a frame thickness of 25mm, we need 32mm bolts with 1 washer each. And the calipers require 5 to 7mm of thread sticking out of the frame. So I'm going to measure that one too. And here we have 6mm, so everything is exactly as it should be. On the fork I was in for a little surprise because the A dimension here is 32mm. That means this fork can take 180mm rotors, which is not that usual for road bikes, but something that I, as a heavier person, can appreciate. It also means that we have to flip the bracket on the caliper into the F0 position. And don't forget to apply some fresh thread locker, because you won't be able to access those bolts after the installation. And according to the specifications, a front flat mount with the bracket requires 15mm bolts with 1 washer. Before I bolt on the caliper, I reroute the hose through the frame. And for that I have to cut the hose just behind the hood. I'm cutting it because it makes less of a mess than unscrewing it, and we have to shorten it later anyways. We will have to align the calipers later, so for now I'm not bolting them on all the way, I'm just fixing them to the frame. Now's also the time to install some anti-rattle foam sleeve. I'll put that on in multiple smaller sections to make it easier. I'm squeezing it all the way into the chainstay through the bottom bracket, and that's it. It's exactly the same procedure for the front brake. On the front, I will tape the hose to the steerer tube to avoid rubbing in the frame. And I will do that approximately on that height here. And for that, I'm just using some electrical tape. Before installing the front now, for the final time, don't forget to put plenty of grease onto the bearings. You can also put some grease on the interface into the head tube. And now the rubber band comes in handy again. At this point, don't mix up the left and the right cable. I've marked the right one with a piece of tape. And then I can install the compression ring. It has a cutout, and that cutout goes to the front where it leaves space for the cables. On top goes the bearing cover, and the cables go through that little opening in the front. And on top of that goes my one 5mm spacer. I don't own a routing kit, so the next part could end up in a disaster, because now I have to get the hoses into the integrated handlebar. And I'll start with the shorter one for the front brake. I'm using this little hook tool here to get it out. That went way easier than expected. That was no struggle at all. And now the rear brake. That was as easy as the first one. So I successfully saved the money on the routing kit. When mounting the handlebars, it's again time for some carbon assembly paste. Now only the top cap is left. Ta-da! And now for the first time ever, we don't need the rubber band, and we can check if the steering is working as intended. I can hear nothing and I don't feel any resistance, so I think I did a good job. Now we can slide on the levers in roughly the final position, but don't tighten them all the way yet. We will still need a little bit of flexibility for connecting the brake hose. When it comes to connecting the hoses or the bleed process, it could be that some of the DOT 5.1 fluid drips out. And you can read some pretty wild opinions on this on the internet. I don't think it's that dangerous. Just read the safety sheet and make of that what you think. You obviously shouldn't rub it into your eyes and you should avoid getting it on the painted surfaces. But if that happens, you can just wash it away with some soapy water or get a bottle of isopropyl. This stuff is really great at cleaning any painted surfaces without being too aggressive to the bike or your skin. Before we can connect the hose, we have to get the remaining piece out. We must not use the old olive and the old barb fitting again, but we have to recycle that fitting here. So that goes into the trash and that goes onto the new hose. Before you cut off the hose to the correct length, I suggest you push as much hose as possible back into the bike. Because every time you replace the cockpit or replace a lever, you have to cut a little bit off. So it's good to have these extra centimeters in there. Don't use normal pliers for cutting the hose. Use a hose cutter. I have the cheapest one possible, but it does the job. A new Stealth-O-Magic barb fitting goes into the hose, but first I'll dip it into some dot compatible grease. Don't over tighten this, just screw it so far in that the gap disappears. Now don't forget to put on the compression nut and then put on a brand new olive. Now again put grease on all these threads and then insert everything into the lever. With the SRAM bleed kit you get this adapter, and with this you can use a torque wrench with the compression nut. And the specified torque is 8 Newton meters. Now just make sure to remove all the remaining grease. And then the brake install is complete. I won't be covering the entire bleed process. The official SRAM video does a great job with that. Just some additional words of wisdom. Be very careful with all these fittings. The tiny O-rings get easily damaged, so stick to the torque specs. Then I would suggest to strap the lower syringe to the fork like that, because this way all the air bubbles can collect at the top. If you would just leave the syringe hanging, you would draw all the air back into the system and you would gain nothing. And then it's a good idea to strap some paper towels to your lever, because you don't want dot fluid leaking under the hood cover. Finally, a quick word on bleed blocks. From my understanding, SRAM specifies this black block for all electronic road group sets, but I now own 3 of them and not on a single one have I ever been able to fit this block. And it's not an issue of the pistons not retreating far enough, I think the caliper is just too narrow. So for the past couple of years I've been using this one instead and it gave me good results. But now I was surprised to see that the new force brake comes with this universal bleed block. And I've just used this in the back and it gave me good results, so stop wasting your time with these. This one here is far superior. Now that the bleeding is complete, the finish line is in sight. We only need the drivetrain now. I will start with the bottom bracket, and I've talked about this a little bit in the last video. It's just the standard one from SRAM, and to get that in, you will need this 16 notch tool. But careful, this is not the same 16 notch tool that we used in the wheel build. This one has a diameter of 52.2 millimeters. You can get this in aluminum or in steel. With this bottom bracket we have a lot of interface, so the chances of slipping are not that high, and we can use the aluminum one that is a little bit softer and won't scratch the bracket. But with the 85.5mm bottom bracket, for example, you won't have as much interface for the tool to grip, so in that case I would go with a steel tool. I will start by putting plenty of grease onto the threads. The 2 sides are labeled with left and right, so there's no way to get them wrong. Just make sure that the brake hose is not in the way, and it also has an arrow on it so you know which way to turn, and it should go in easy like that without any force. Now the other side, and now use a torque wrench to tighten it to 50 Newton meters. Next up is the crankset, but before I put that in I will swap out the pre-installed 42 chainring for 46. The gearing range of the 42 would be perfectly fine for me, but especially when racing I want to be a little bit higher up the cassette so that I have more gearing options at speed. And also I want to try this as a road bike, and on the road you won't get anywhere with a 42. So 46 it is for now. The swap is easy, just loosen the 8 bolts with a T20 Apply some fresh thread locker and put on the new chainring. It only goes in one way, and that's with the little torque specification aligned with the crank. And to finish it off, make sure that every single bolt is tightened with 4 Newton meters. In this case, you can check them multiple times, because by tightening one bolt, its neighbors will get loose a little bit again, and so on. The crank already comes with some grease applied, but it won't hurt to put in some more. Before the crank goes in, it's very important to install the correct spacers, otherwise your chain line would be off in the end. For a T47 bottom bracket and a wide crankset, we need 5.5 mm on the drivetrain side and 2.5 mm on the left side. And the spacers go in with the SRAM logo facing to the outside. Make sure the preload adjuster sits all the way on the outside, and then the crank goes into the bottom bracket. And tighten that to 54 Newton meters. I'm bringing my bike stand to its limits. Did it. As you can see, there's still a little play in the system. To take that out, we push everything to the non-drive side and give the drive side a little whack. Now we can take the play out with the preload adjuster. Just turn that gently onto the spacer and then secure it with a tiny 2 mm hex key. But be very careful, this bolt sits in plastic, so it's very easy to ruin the threads. And that completes the crank installation. And don't get fooled by these spin test videos, they tell you nothing about how a bottom bracket under load works. It's totally normal to have some friction with greased and sealed bearings. Now there's just one big component missing, and that's the rear derailleur. This frame is UDH compatible, meaning that we can use SRAM's full mount derailleurs that bolt directly to the frame instead of using the traditional derailleur hanger. So step 1 is to remove that derailleur hanger. The cage of an XPLR derailleur can be fixed in 3 different modes. This is how it would look like in normal operations. If I open the cage and press the cage mode button in this position, the derailleur is now in setup mode. If I open the cage even further and press the button again, the cage is now in open mode. To close it, I just push the cage even further, the button snaps back and the cage closes automatically. Be careful, do not pinch your fingers, because this will slap with some force if you let it. Before mounting the derailleur, make sure that the frame is clean. Remove the mount bolt and the bushing frame insert from the derailleur. Insert the bushing frame insert into the frame. Grease the mount bolt and then mount the derailleur. Tighten the bolt and then loosen it back up by 1 revolution. Then put the derailleur into the 6th cock position and put it into the open mode. Now it's time to install the wheel. And then loosen the through axle by 1 full turn like you did with the derailleur mounting bolt. I've already waxed the chain, but before I can install it, I have to figure out the correct length, and I'm doing that by using the SRAM app, and it says that I need 120 links. That means I have to shorten that full-size chain by 6 links. I'm reaching the limits of my studio here, but I still hope you can see what I'm doing. So we've put the derailleur into the 6th cock position, and the 6th cock is also marked with a red piece of plastic. And I will now put on the chain over the 6th cock. And I'll start from the bottom, go over the 2 pulley wheels and over the 6th cock. I'm now connecting both ends with a power lock, and to fully close the lock, I will now lock the rear brake and give the crank 1 big push. And that sound was the lock closing. It's now time to bolt the derailleur on in its final position. For that, put it into the setup mode. In the setup mode, tension the chain a little bit and check that it's still running on the 6th cock. If that's the case, keep tension on the chain and tighten the bolt. Make sure that the silver mark on the knurled ring is aligned with the white mark on the full mount. If that's not the case, loosen the bolt a little bit again and adjust that. If everything is in place, the bolt gets tightened with 35 Newton meters. And don't forget to tighten the through axle to spec on the other side. And if the cage mode button is still engaged, just push down on the cage until it pops out. That's it. Now you can test the shifting and adjust it with the micro adjust function in the app if necessary. Now is a good time to adjust the brake calipers before I put the bike on its own feet for the first time. My preferred method is to look along the rotor and adjust the caliper so that the gap left and right of the rotor is the same. It helps to do this against a bright background, or if you don't have that, just use a light or your phone screen. I'm so close to just abandoning this video and going for a bike ride instead, but there are still a few finishing touches we need to put on. The alignment of the brake calipers went really well, so Quick did a great job at facing the brake mounts. In the meantime, I've also straightened the handlebars, aligned the levers and tightened the stem bolts with 5 Newton meters. In the last video I've talked about adding a chainstay protector, but even in the smallest cog there's quite some gap here, and the chain tension with the XPLR derailleur is so high that I don't think that will be necessary. So for now I would just leave it with the pre-installed protective film. Bar tape is the Zip cyclocross tape. I'm using this for the first time and so far I like it. It's really stretchy and that makes it easy to apply. I wouldn't consider myself a bar tape artist, but I'm getting better every time. Whether you are wrapping from the top or the bottom, it's important to do it in the correct direction, because when you're gripping the bars really hard, you're turning your hands inwards or backwards, and you have to wrap in that direction as well, otherwise you would loosen up the tape over time. Purists will have to look away now because I'm using a little piece of double-sided tape in the area of the tightest radius, because it will make the tape last much longer. I will also tape on this little cover piece, because in this location we will swap wrapping directions and this will cover up the gap created by this. I'm going to cut off the part of the tape without the sticky stuff. And then I will start the wrapping on the bottom of the tube with some overlap that we can push into the bar later. And you want to overlap the tape so that the sticky stuff always contacts the handlebar. When approaching the radius, make sure that you still have enough overlap on the longer side. And now you can see how that little cover piece covers the clamp, so this is just for the optics. To finish it off, cut the tape at an angle and then secure it with either finishing tape or some electrical tape. I could have made my life a little bit easier here with more overlap, but this will work. Not my best job, but it will do. And with black on black, no one will notice. This is the state in which many brands state their weights, so let's see where we're at. 7.35 kilos. So we are on the road to sub 8 here. On to the final details. I'm using this computer mount that came with the handlebars and I'm pairing it with this light mount that I found on AliExpress. And with that, the light isn't dangling here in the front, but instead is safely secured directly to the mounting bolts. But it also means that I have to use longer bolts. I will mount a pair of Shimano XT pedals. Now we need the little washers that come strapped to the cranks. And here I'm not just using grease, I'm using anti-seize, and this stuff is nasty. Don't get this anywhere near your clothes. Bring the crank into this position and then you can easily tighten it with 35 Newton meters. And now the very last items, a pair of Elite Cannibal XC bottle cages. And the final weight ready to race is 7.82. Not bad for a gravel bike, not that it would matter with a body weight of over 90 kilos, but that's still impressive. Summer has returned, just in time for the first shakedown ride. I wanted to keep the bike clean for these shots, so it hasn't seen much action yet, but so far I really like it and it feels like a modern gravel bike should feel. The fit is still a few millimeters off because of the seat post, but that won't stop me from putting plenty of kilometers on it in the next few days. But that will come in the next video, so subscribe and see you there.